Good morning, Mr. Andy. Today I'm here with my team, Marvin, Evelyn, and Sam, and we'll be presenting about natural resources. So the first one we have lead. So lead is a metal element with the atomic number 82 and is presented by Pb in the periodic table. In solid form, it has a gray color, and in liquid, it has a shiny chrome silver color. So it is used to make batteries for vehicles, wheels, weights, and other parts. Also for electronics and communications. Next slide. Next slide. Now, the process to extract lead is from underground ores that contain sulfur, and the ore is then poured into a tank filled of water to separate from sulfur, and the water is then pushed through a filter, which removes 90% of the water and leaves a concentrate of lead of about 40 to 80%. And its distribution in Indonesia is in Aceh, Lampung, South Sumatra, Bengkulu, West Java, West Kalimantan, Central Kalimantan, Nusa Tenggara, and South Sulawesi. The next element is gemstone. So it is a piece of mineral crystal which is cut and polished, and it is used to make jewelry or other adornments. And nowadays, some is even used for spiritual practices. Next. So the process to get gemstone is when a rock is worn down and the fragments of mineral-rich water seeps down into the cracks and cavities in the earth's surfaces. And this becomes deposits of minerals, which becomes gemstones over time. And the distribution in Indonesia is in Bengkulu, is in Sumatra, Java, North Maluku, and Kalimantan. Next. The next mineral is bauxite. And bauxite is a sedimentary rock with a relatively high aluminum content. It is the world's main source of aluminum. So it is again used for making aluminum metal and chemical industry, and also for building materials. Next. So the process to get bauxite is through a Bayer process. You can see in the diagram by yourself. And it's a bit difficult to explain it. So if the process is called Bayer process. And then the distribution in Indonesia is in Central Kalimantan, West Kalimantan, Bangka Belitung, and Riau Islands. Next resources is nickel, which is a chemical element with the symbol Ni and atomic number 28. It is silvery and white metal with a slight golden tinge. Nickel is also hard but ductile. So because it is hard and ductile, it is usually used with other metals like iron or copper to produce alloys. It is used for coating batteries and kitchenwares. Okay. So to get nickel, it is from deposits of magmas that is derived from Earth's mantle ascend into the crust. And then it crystallizes into magnesium nickel rich mafic and ultramafic rocks. And then its distribution is in Sulawesi Selatan, Halmahera, Sulawesi Tengah, Sulawesi Tenggara, and Tanjung Buli, also in Halmahera. And then my last resource is copper, which is a chemical element with the symbol Cu and atomic number 29. Copper is soft, malleable, and ductile, and it has a high thermal and electrical conductivity. Its color is pinkish orange. It is also used in electrical equipment such as wiring and motors because it's very conductive and it is ductile. Next. So to get copper, it is a metal that has been deposited from hot sulfur solutions created in volcanic regions. And the hot solutions concentrate the copper up to 1,000 times more than would normally be found in rocks. And then the distribution in Indonesia is in Jawa Timur, Central Kalimantan, Central Sulawesi, and Papua. Now I'll pass on the role to the next person.
Okay, so the first resources that I researched is petroleum. Petroleum is a complex mixture of hydrocarbons that occur on Earth in liquid, gaseous, and solid form. The usage is for transportation fuels, oil for heating and electricity generation, asphalt, and rock oil. So the distribution in the world, there's in United States, Russia, China, Venezuela, Mexico, Libya, and Brazil, while in Indonesia, in Sumatra, Java Sea, East Kalimantan, and Natuna Island. The process itself, it takes millions of years, and the plants, algae, and plankton from the oceans, they were buried and crushed under millions of tons of sediments and even more layer of plants. And then they compress between the Earth's metal with high temperatures, and with more heat and time, they become uh, they and went into a process called catalgenesis and transformed into hydrocarbons. And sedimentary basins where oceans been used to lie are key source of petroleum. Next. Then the second one is natural gas. Natural gas is naturally occurring hydrocarbon gas mixture consisting of methane and commonly including varying amounts of other higher alkanes and sometimes a small percentage of carbon dioxide, nitrogen, hydrogen, sulfide, or helium. It is used to heat buildings and water, to operate refrigeration and cooling equipment, to cook, to dry clothes, and to provide outdoor lighting. In the distribution in the world, there's Russia, USA, Canada, West Asia, South Asia, East Asia, Europe, and Africa, while in Indonesia there's in Aceh, East Kalimantan, Papua, and also Natuna Island. The process itself are almost the same like petroleum, and they underrun into pressure and heat, so they can change into petroleum and some other natural gases. Six. And then this third one is coal. Coal is a combustible black or brownish black sedimentary rock formed as a rock strata called coal seams, and its most variable amounts of other elements such as hydrogen, sulfur, oxygen, and nitrogen. It is used as a source energy for generating electricity, produces of gas products, and etc. The distribution in the world, there's in the United States, Russia, Australia, China, and India. While in Indonesia, there's in Tarakan, Kutai, Barito, Bengkulu, Central Sumatra, and South Sumatra. The process itself is formed due to partial decomposition of that matter, and then due to the accumulation of matter underwater, which cut off the oxygen supply. It is ductile matter formed due to pressure, and it consists of process of plants. It formed due to added pressure, uh, and then it became a soft coal, and then because after another high pressure, high temperature, and long period of cold, a long period of time, it became hard, lustrous, and has the highest percentage of carbon among peat like lignite, bituminous, and anthracite, and it's called as the hard coal. Next. And then next one is clay. Clay is type of fine-grained natural soil, material containing of clay materials. Clays develop plasticity when wet due to a molecular film of water surrounding the clay particles that became hard, brittle, and non-plastic upon drying or firing. It is used in many modern industrial processes such as pepper making, cement production, and chemical filtering. The distribution in the world in United States, China, and Ukraine, and Germany, but Indonesia, it's almost in all of Indonesia. The process is from minerals, plant life, and animals, and for time, water pressure breaks up the remains of flora, fauna, and minerals, and then it became the fine particles. Large particles are filtered out through the rock and sand, leaving still to settle into beds of clay. Next, last one that I'll present is the kaolin. Kaolin is clay material with chemical compositions Al2, Si2, O5, OH4. It is an important industrial mineral. Uh, Rocks that are rich in kaolinite are called kaolin. Kaolin is an essential ingredient in the manufacture of China porcelain, and it's widely used in the making of paper, rubber, paint, and many other products. Next. And the distribution in the world in Malaysia, Pakistan, Vietnam, Brazil, Bangladesh, Bulgaria, France, Indonesia in West Kalimantan, South Kalimantan, Bangka Belitung Island. The process itself is formed by weathering or hydrothermal alternations of aluminosilicate minerals. Then rock enriched feldspar, commonly weathered to kaolinite, in order to form ions like Na, K, Ca, Mg, and Fe, must first be leached away by the weathering or alternation process. Then I'll give to the next presentation.
Okay, thank you, Evelyn. Now I will start with my natural resources. First, we have limestone. Sorry. Lead is a carbonate sedimentary rock. It is composed mostly of the minerals calcite and aragonite, which are different crystal forms of calcium carbonate. Limestone forms when these minerals precipitate out of water containing dissolved calcium. The usage is construction and architecture, agriculture, steel industry, sewage disposal system, industrial fillers. And I'm sorry, it is supposed to be limestone. Okay. So the distribution of limestone. In the world, we have the US, India, China, Brazil, Japan, Germany, and South Korea. In Indonesia, limestones are located in the West Sumatra region, East Java, Central Kalimantan, and also East Kalimantan. So how does it form? Limestone is a sedimentary rock, as we have known before. It is commonly formed in clear, warm, shallow marine waters. It is usually due to the accumulation of shell, coral, algae, and fecal debris. Next, we have sand. Sand is a granular material composed by finely divided rock and mineral particles. Sand has various compositions, but it is defined by its grain size. Sands are usually smaller than gravel and coarser than silt. The usage is construction of roads, land regeneration project, making glass and silicon chips. In the world, sand is located almost everywhere, but the main exporter or importer of sand is the US, India, China, Australia, and Sierra Leone. In Indonesia, we have Sumatra, Java, Kalimantan, Sulawesi, Nusa Tenggara, and Papua. Now, how does sand forms? So sand forms when rocks break down from weathering and eroding over thousands or even millions of years. Rocks take time to decompose. If you see here, this is the picture of weathering, erosion, and deposition. Next, we have quartz. Quartz is a hard crystalline mineral composed of silica. The atoms are linked into a continuous framework of silicon-oxygen tetrahedra, with each oxygen being shared between two tetrahedra. So the usage of quartz is normally found in jewelry, glassmaking industry, refractory industry, and also the petroleum industry. It is distributed in Russia, Madagascar, China, Brazil, and US, and all the other parts that are highlighted by the color red. In Indonesia, we find quartz in North Sumatra, East Java, Central Kalimantan, and Central Java. It is formed when magma cools. Next, we have iron. Iron is a brittle, hard substance classified as a metal in the group 8 of the periodic table. The most abundant of all metals is iron. Iron is also known as ferrum or Fe in Latin. The usage of ferrum or iron is construction, steel production, cutting tool, and home appliances. The distribution in the world is in Russia, Australia, China, Ukraine, and Canada. In Indonesia, we find iron in Banten, Central Sulawesi, South Kalimantan, and Central Java. Now, the process of iron formation is when a red giant star, so this is the red giant star, turns all of its helium into carbon and oxygen atoms. Those atoms then begin to turn into iron atoms. And when it explodes, the space will be showered with iron, oxygen, and carbon atoms. Marble. So marble is a metamorphic rock composed of recrystallized carbonate minerals, most commonly calcite or dolomite. Marble is typically not foliated, although there are exceptions. In geology, the term marble refers to metamorphosed limestones. The usage of marble we find in buildings and monuments, interior decoration, soil treatment, and also cemetery markers. The distribution in the world is in Italy, China, India, and Spain. In Indonesia, we often find it in East Java, West Sumatra, West Papua, and Aceh. The process of marble is when limestone is heated and pressured in the Earth's crust. So these forces cause the limestone to change in texture and makeup, which is called recrystallization. And finally, after a long period of time, marble will be formed. And now I will pass it on to the next presenter, which is Samuel.
Okay, thank you, Marvin. So the definition of gold. Gold is defined as a soft yellow precious metal, or the color that is a mix of yellow and olive brown. An example of gold is the substance from which some jewelry is made. And the usage is today, gold still occupies an important place in our culture and society. We use it to make our most prized object, wedding rings, Olympic medals, money, jewelry, Oscars, Grammys, crucifix, art, and many more. Next, Marvin. So the process in obtaining gold from vein ore, the ore is first crushed in wrought or ball mills. This process reduces the ore to a powdery substance from which the gold can be extracted by amalgamation with mercury or by placer producers. About 70% is recovered at this point. Once extracted, the gold is refined with one of four main processes: flotation, amalgamation, iodination, or carbon in pulp. Each process relies on the initial grinding of the gold ore, and more than one process may be used on the same batch of gold ore. And the distribution in the world is we can find in Russia, South Africa, US, and Indonesia. Next, Vin. And the next is silver. Process. Silver is a soft, white, precious, univalent metallic element having the highest electrical and thermal conductivity of any metal. Occurs in argentite and in a free form. Used in coins and jewelry and tableware and photography. AG. Atomic number 47. Silver, coin made of silver. Usage. It is used for jewelry and silver tableware, where appearance is important. Silver is used to make mirrors, as it is best reflector of visible light known. Although it does tarnish with time, it is also used in dental alloys, solder and brazing alloys, electrical contacts, and batteries. In process, silver is extracted from lead ores in large furnace. A process called cupellation. Most silver is extracted from ores with a froth flotation process, which was discovered early in the 20th century. In the process, crushed ore is placed in a bed. Distribution. Silver can found across many geographies. About 57% of the world silver production comes from the Americas, with Mexico and Peru supplying 40%. Outside of the Americas, China, Russia, and Australia combine to make up nearly 22% of the world's production. And next, the definition: a non-metallic chemical element that is an essential element for all life, resembles oxygen in chemical properties, and is used especially in the form of sulfuric acid to extract phosphates from ores. The usage is the greatest commercial use of the element is the production of sulfuric acid for sulfate and phosphate fertilizers and other chemical process. Sulfur is used in matches, insecticide, and fungicides. Next. Sulfur is an essential element for the macromolecules of living things and released into the atmosphere by the burning of fossil fuels, such as coal. Sulfur can also fall directly from the atmosphere in a process called fallout. Also, the weathering of sulfur containing rocks release sulfur into the soil. The distribution. Sulfur is found both in its native form and its metal sulfide ores. It occurs in its native form in the vicinity of volcanoes and hot springs. Sulfur is the 10th most abundant element, and it is found in meteorites and in the ocean, in the Earth's crust, in the atmosphere, and it's practically all plant and animal life. Next one. The next. Manganese is a pinkish gray, chemically active element. It is a hard metal and it's very brittle. It is hard to melt, but easily oxidizes. Manganese is reactive when pure, and as a powder it will burn in oxygen. It reacts with water and dissolve in dilute acids. The usage: manganese is used to make clear glass, to desulfurize and deoxidize steel in steel production, and to reduce the octane rating in gasoline. It also used as a black-brown pigment in paint and as filler in dry cell batteries. Its alloys help stiffen the aluminum in soft drink cans, according to chemical. Next. Process. Pure manganese is produced by hydrometallurgical and electrolytic process, while ferromanganese and silicomanganese are produced by the smelting of ores in a blast furnace or more commonly in an electric furnace. Smelting is further complicated by the action of the gangue oxides. The distribution, according to USGS, manganese resources are mainly distributed in South Africa, 150 million tons, in Ukraine 140 million tons, Australia 97 million tons, Brazil 54 million tons, in India 49 million tons, China 44 million tons, Gabon 24 million tons, and Mexico 5 million tons. And then the next, phosphate in a salt of phosphoric acid. Phosphates are important in biochemistry. Phosphates have the formula PO43 and a molar mass 94.973 G per mole. An example of phosphate is sodium phosphate. The usage: phosphate rock is processed to produce phosphorus, which is one of the 3 main nutrients most commonly used in fertilizer. And the other 2 are nitrogen and potassium. Phosphate can also be turned into phosphoric acid, which is used in everything from food and cosmetic to animal feed and electronics. Next. And the process: the dried phosphate is the most commonly processed into what are referred to as ammoniated phosphates. This is done by reacting the phosphate rock with the sulfuric acid to produce phosphoric acid. The phosphoric acid is then reacted with ammonia to produce the ammoniated phosphate MAP or DAP. Distribution: 14% stored as intracellular phosphate, 1% in extracellular fluid. Circulating phosphate is 45% freely in ionis, 15% protein bound, and 40% complex with sodium, calcium, and magnesium. The next is mica, any of a group hydrous potassium aluminum silicate minerals. It is a type of phyllosilicate exhibiting a two-dimensional sheet or layer structure. Among the principal rock forming minerals, micas are found in all 3 major rock varieties: igneous, sedimentary, and metamorphic. The usage: the major use of sheet and block mica are as electrical insulators in electronic equipment, thermal insulation, glass, window in stove, and kerosene heaters. Dielectrics in capacitors, decorative panels in lamp and windows, insulation in electric motors and generator armatures, field coil insulation. Process. Mica is ground dry to yield finely defined mica particles prior to forming a sheet. A single sheet of uniform thickness is formed at one time by pouring a colloid mixture of the ground mica, water, and a colloid agent onto a mesh screen. Vacuum means a hydraulic press are used to complete the formation of sheet. Distribution. Mica is produced in Jharkhand, Andhra Pradesh, Telangana, and Rajasthan, followed by Tamil Nadu, West Bengal, and Madhya Pradesh. Jharkhand high quality mica is obtained in a belt extending to the lower Hazaribagh Plateau. Rajasthan belt extend from Jaipur to Bhilwara and around Udaipur. And that's it.
Okay. Thank you for listening to our presentation, Mr. Andy. We hope you have a nice day. Thank you.